Hello, Digital Earth. My name is Dekyvere and I'm from Belgium. This semester I'm on an Erasmus exchange program to Bulgaria. Here I study geodesy at UACG. My hobbies are hiking and reading, but especially hiking. I already went hiking in Scotland on the West Highland Way, Bulgaria, the Musala Mountain, and Iceland in the region of Randmanalogur. But today I'm going to talk about a technique called INSAR. INSAR is an abbreviation that stands for Interferometric Synthetic Aperture Radar. And in this movie I will try to explain the basic principles of INSAR, starting with radar. Radar is an active remote sensing technique, which means that a satellite sends a signal to the Earth and picks it back up. This signal, when we look at the electromagnetic spectrum, is a microwave, because a microwave can pass through clouds and can be used at night. So radar tries to measure the distance between a satellite and the Earth. Uh, this by measuring the time and by knowing the speed of the signal. If we combine this, we can measure the distance. Synthetic aperture. We start in the world of photography, where the sharpness of a picture is determined by the opening of the lens, and this is called the aperture. With INSAR, the lens is an antenna, and the sharpness is determined by the width of the antenna, which means we would need a really wide antenna, which is impossible. That's why there is synthetic aperture. When we look at the satellite at two different moments along his path, we have the physical antenna on the satellite itself, but we can also create a synthetic antenna between the two different positions. Interferometric. We first take a deeper look at the signal. We have the amplitude of the signal, which gives us amplitude image, where we recognize some topography. Then we also have the phase image, which looks like random noise, but if we combine two phase images, we can create an interferogram, which leads to 3D models. The applications of INSAR are millimeter scale changes, like the subsidence of buildings, but also surface deformation mapping, like for example around an earthquake, a volcano, or a landslide, and of course creating digital elevation models. This is the end. Thank you.